Now let us try to find the Cartesian form for the formula which gives us the distance between the given point A and the given plane. So let the coordinates of the given point be x1, y1 and z1. And let the Cartesian equation of the Cartesian form of the equation of the given plane be given as ax plus by plus cz is equal to d. Now comparing it with the equation which we already know, r vector dot n vector is equal to d, we have n vector is equal to ai plus bj plus ck vector. So we also know the distance, perpendicular distance from A to B, where B is the foot of the perpendicular drawn from the given point to the given plane. So we know that the formula for that is equal to A vector dotted with n vector minus d, the whole upon magnitude of n vector, where A vector is nothing but the position vector of A. So that will be given as x1i plus y1j plus z1k. Yeah. So on performing the dot operation between a vector and n vector, we have ax plus, okay, let's take it as x, y and z only. So we don't have any other thing. So ax plus by plus cz minus the distance here is d, the whole upon magnitude of n is going to be root of a square plus b square plus c square. So this is the Cartesian form for the formula which gives us the distance between the given point and the given plane.